This is a powerful, thought-provoking hook. Have you ever wondered if everything that's ever going to happen is already decided? Imagine if you knew the exact position and speed of every single particle in the universe. According to classical mechanics, the laws of physics would then let you predict the entire future, moment by moment, forever. And not just the future, you could also perfectly reconstruct the past. Now, that might make you a little uncomfortable. You're probably thinking, hold on, I make my own choices. I decide what I have for breakfast, I decide what to watch tonight. I'm not just a cog in some giant cosmic machine, am I? Well, you've just stumbled upon one of the deepest questions in science and philosophy, one that brilliant minds have debated for centuries, and guess what? They still don't all agree. My name is Sean Carroll. I'm a physicist and philosopher at Johns Hopkins University. I host the Mindscape podcast, and I've written a few books about these big ideas, like the Biggest Ideas in the Universe series. Today, we're going to dive into this mind-bending concept, the determinism of classical mechanics. Is our reality just a giant, predictable clockwork machine? Let's find out. Physics can seem really difficult, right? All those abstract concepts and complicated equations we don't use in our daily lives. But here's a paradoxical thought. Maybe physics seems hard because at its core, it's actually easy. Or, to be more precise, its power comes from simplification. When physicists study the world, they do something very clever. They strip away all the messy, complicated details to find the fundamental, simple rules underneath. Think about your high school physics class. You probably learned about things like frictionless surfaces, perfect spheres rolling down inclined planes, or pendulums that swing forever without air resistance. Of course, in the real world, no surface is truly frictionless and no pendulum is perfect. These are idealized models. Physicists intentionally remove all the extra complications to isolate the universal patterns. Once they understand those core principles, they can start adding the complexity back in, layer by layer, to get closer to the real world. This reductionist strategy is incredibly powerful in physics, but it wouldn't work so well in other fields. You can't really simplify human psychology or global politics down to a few neat equations. But for understanding the fundamental